Welcome back to the Aurora Tech channel. Today, I will review the Creality HI, an entry-level bed slinger that supports multiple color printing. The printer itself costs $369, and if you want to purchase it with the CFS, the combo price is $519, which adds $150 to the base price. Let's take a look at what this printer offers. The print volume is 260 by 260 by 300 millimeters. It's about 68% larger than a standard bed slinger and a little over 20% larger than the BambuLab A1. Despite the increased volume, the overall size remains in line with other bed slingers, requiring about 24 by 17 inches of table space and a height clearance of 28 inches, including the spool holder and filament. The motion system features linear rails on the x-axis, steel wheels on the y-axis, and dual lead screws on the z-axis, controlled by independent stepper motors and drivers. The gantry is leveled using two limit switches at the top, and both the X and Y stepper motors are closed loop. The extruder is a direct drive system with metal gears. The print head features a cutter that trims the filament during color changes, similar to BambuLab machines and the Creality K2 Plus. Inside the print head, you'll find a built-in filament sensor and accelerometer. Auto Z offset and auto bed leveling are handled by a strain gauge using the nozzle as the probe. The printer also has dual-part cooling fans and a hot and fan, all of which are closed-loop controlled. The maximum claimed speed is 500 millimeters per second with an acceleration of 12,000 millimeters per second squared. The nozzle temperature can reach up to 300 degrees Celsius, while the heated bed can go up to 100 degrees Celsius. The build surface is a new double-sided epoxy-coated plate. The nozzle is a tri-metal design with a hardened steel tip, allowing it to print abrasive filaments like nylon carbon fiber straight out of the box. The motherboard runs on a dual-core ARM Cortex-A7 processor with 8 gigabytes of storage. The 3.2-inch touchscreen features a custom UI. The default slicer of the printer is Creality Print. Additionally, it has a built-in profile in Orca Slicer. Creality Cloud is optional. You can send prints via your local Wi-Fi network or print offline using a USB drive. For additional features, it includes an HD camera for print monitoring and time-lapse recording, an LED light, and a privacy cap for the camera. The printer also has clean cable management. I'd like to thank Creality for sending us this machine to review and for sponsoring today's video. Even though this is a sponsored review, we won't hesitate to point out any cons of the machine. With that said, let's get started. The machine I received is the combo version. This large box includes the printer and the CFS. On top, we have the CFS well protected by foam with the printer placed underneath. The package includes the printer, spool holder, a hub that allows you to connect up to 4 CFS units to print 16 colors, a power cord, some general tools, short Bowden tubes, and cables for the CFS. The CFS unit is the exact same as the one with the K2 Plus. To mount the gantry on the base, you don't have to flip it over. Simply secure these 4 screws, connect the dual Z motors, and put on the protective covers. There are 2 more screws at the back, then connect the cable from the base to the print head by running it through these 2 cable clips. Next, mount the spool holder at the top, install the Bowden tube coupler, and secure the Bowden tube, which acts as a filament guide to the extruder. Now, we can turn on the machine. Start by selecting the language and ensuring there are no objects on the print bed. Then, agree to whatever it says on the screen, followed by connecting to your home Wi-Fi network. It only supports 2.4 GHz network, and use the touch screen to enter your password. After that, select the time zone. The Creality Cloud connection is optional, so for now, I will skip it and print within my local network. A self-check screen will appear, and we'll let it run. It checks all the motors, heaters, and fans. After that, it performs input shaper calibration. Once complete, before it starts auto bed leveling, the print head moves to the back and uses the edge of the print surface and the cleaning pad to clean the nozzle, as it will use the nozzle to probe the bed. And then moves all the way up to align the gantry, similar to Prusa machines. It then probes a 7x7 grid for bed leveling, starting from the center. With calibration done, we can now load filament. If you are using Creality Hyper PLA with RFID, simply tap the reader with the filament spool and it will detect and enter the filament type and color for you. If using other filaments, you have to set it manually on the touchscreen. Once the filament is heated to the desired temperature, it starts loading, flushing, and purging twice. We will start with a sample G-code. Let's try this 24-minute high-speed test print. Since we haven't connected the CFS yet, it will just use the spool holder, which is fine for now as we're starting with single-color prints. The first layer is not printing too fast, but from the second layer onward, the speed increases significantly. Let's do a sound test. The sound meter is about 1 foot away, and the noise level stays in the mid-50s most of the time, occasionally jumping to the high 50s. The print finished in 23 minutes, which is pretty fast for something this size, even though it's just a single wall model. The layers look fine, so I suppose everything is working normally. We will then try printing a fast Benchy, starting with the one preloaded on the printer. The estimated print time is 13 minutes. When calibration is selected, before every print starts, it will redo the 49 points auto bed leveling. After that, the print will start as normal. The first layer is printing quite fast, at approximately 100 millimeters per second. After a few layers, the machine is printing even faster. The sound level is in line with the last print. It stays at around the mid-50s and occasionally jumps to the high 50s. The print finishes in 15 minutes. The layers are 0.25 millimeters height, which still looks alright. However, the cooling of this side isn't look good. The line width seems a little wider than normal, but the top still looks fine. Let's try a normal one using the slicer default profile with a 0.2 millimeter layer height. This time, it took 43 minutes. Let's compare them side by side. The 43-minute one was printed at 0.2 millimeter layer height. The surface as well as the chimney both printed better. The cooling issue that appeared on the 15-minute Benchy doesn't show up on this 43-minute one. From the top, the line width of the 43-minute one is narrower and the surface is smoother. As this machine uses the same cut and poop method as BambuLab's machine, I will also print the preloaded poop tray. It looks like the first layer printed beautifully. For a larger print like this, it allows the print head to accelerate even faster, and the extruder can keep up with the speed. It finishes in 3 hours, 18 minutes. I just peel off the brim so it's not as good as using a deburring tool. The bottom was printed very well, and it fits and functions as expected. It looks even better after I use a deburring tool to clean up the edges. Okay, we will then try some benchmark test prints, starting with the number slider to test the clearance. It finishes in 2 hours 49 minutes. It's not super fast, but fall within the average time of 2 hours 30 minutes to 3 hours of the same model printed by other clipper machines. The top looks good with minimum stringing, the bottom also printed alright with good clearance. All tiles can move freely. Up next, I will print the Honeycomb box. It starts with printing some tiny honeycomb patterns on the first layer. Then, print a tiny bit of filament and retract immediately. The print finishes in 2 hours 45 minutes, not the fastest, but in line with other latest printers. The retraction of the extruder is very good, the patterns printed perfectly. The bottom also printed very well, virtually no stringing. Let's put it side by side to compare with the same model printed by other machines. It's one of the best, if not the best. Then, I will print my simple geometry model to test the tolerance and see the parts can fit with each other. It finished in 1 hour and 27 minutes, which is about average. On the square side, it clears up to 0.075 millimeters and gets half stuck at 0.05 millimeters, just one step away from perfect. On the cylinder side, it clears up to 0.05 millimeters and gets stuck at 0 clearance, which is a perfect score. Next, I will print the Robo Alpaka from Prusa to test the surface quality. It finishes in 4 hours 29 minutes, and the surface quality looks alright. Let's take a look from all 4 angles. We will then compare it with other printers, starting with something in the same class. When compared to the BambuLab A1, the Creality HI is 1 hour 8 minutes faster, the surface quality are similar, but I think the A1's still slightly better as these areas are cleaner. Compared with the Anycubic Cobra 3, the Cobra 3 is 12 minutes faster, but the Creality HI has better surface quality. Compared with one of the fastest bed slingers, the Soval SV06 Ace, the SV06 Ace is 29 minutes faster, but the Creality HI surface quality is much better. Compared to the Prusa Mark IV S, the Creality HI is about an hour faster, and the surface quality are similar. Finally, when compared to the new Creality flagship, the K2 Plus, the K2 Plus is 1 hour 14 minutes faster and also has a slightly better surface quality. Let's try some different materials, starting with PETG. My K2 Plus also need a poop tray, so I will print one with PETG. It seems the Auto Z offset also works pretty well on PETG, as I saw many printers normally squeezed a bit too low when the printing temperature increased due to heat expansion. The print finished in 7 hours 48 minutes. It's a pretty large print. The transparent PETG was printed beautifully. The bottom stuck perfectly to the bed. Overall, it's a very nice functional print. Then, I will try some nylon carbon fiber. I dried it for 6 hours before starting the print. This type of new epoxy flexible build plate generally sticks pretty well with PACF. I will try to print without using glue. The print took 1 hour 27 minutes. Once the nylon is dried, it just prints as easy as PLA. Even the small gears were printed nicely. But my propeller designs still have some other parts. I will print the rest with ABS. When printing ABS with this open frame bed slinger, I will apply glue. The print finishes in 1 hour 36 minutes. There is no layer cracking, but as the cooling was minimum or off when printing ABS on this open frame printer, some overhanging areas are not perfect. But when putting all the parts together, it still works as expected. I will then run a first layer test. From previous tests, this printer's Auto Z offset seems pretty accurate, so I will print a 250 by 250 millimeter single layer PLA sheet. The print finished in 38 minutes and peeled off cleanly without any line separation. The result is awesome. This is what I would call a perfect first layer. Finally, let's try the CFS and do a multiple color print. The CFS hub can connect up to 4 units to print 16 colors. However, the machine frame doesn't have any screw holes to mount the hub. Instead, it uses a double-sided tape to fix it on the side. I used 3 spools of Hyper PLA and 1 spool of Creality low-cost soy lane PLA to print this transformer model. I will try to max out the print volume and print 2 of them at the same time. Generally, I wouldn't use glue with PLA on this print surface. However, since this is a 30+ hour print with some small contact areas on the first layer, I don't want to risk it. It uses only 3 colors at first. After about 70%, it also uses the 4th color. The color changing is quite smooth with all 4 colors. Okay, after over 37 hours, the print finally finished. The print looks really nice, and it didn't have any issues from start to finish. It generates quite a lot of poops. The weight of these models is about 400 grams, and the poops weigh almost the same. It's fully functional, and most importantly, it can transform. The only imperfection part is the color change between white and red, as you can see in these areas, as I just use all default settings, but when printing with red and white, it would be better to flush double the amount of filament to make the color changes look even better. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The build quality of this machine is solid, with top-notch hardware, including linear rails on the x-axis, steel wheels on the y-axis, and closed-loop stepper motors on both axes. It maintains precise movement without skipping steps, even at high speeds. Assembly is also very simple, making it beginner-friendly. 2. It has a slightly larger print volume of 260 by 260 by 300 millimeters compared to standard machines. The extra space may not seem like a big deal, but when you need it, you'll be glad it's there. 3. It offers a well-balanced combination of speed and quality, a decent print surface, and strong performance across all my benchmark test prints. 4. The Auto Z offset is one of the best, if not the best. It printed the PLA sheet better than any machine I've tested so far, and consistently delivers a perfect first layer, even with high temperature filaments. 5. The CFS works seamlessly with the Creality HI. I didn't expect the 37.5 hour transformer model to print so well, but it completed flawlessly without errors, jamming, or any issues throughout the print. The included hub allows you to connect 4 CFS units, enabling printing with up to 16 colors. 6. The new double-sided epoxy flexible build plate provides excellent adhesion for PLA, PETG, and even nylon carbon fiber. If you're not printing ABS or ASA, you essentially don't need to use glue. 7. The new Creality Print version 6 has been completely redesigned. While the workflow has improved significantly over previous versions, it's fully functional, but not yet my favorite slicer. However, its ability to efficiently manage multiple Creality machines has earned it a permanent spot on my computer. The best part is that this printer profile is also included in Orca Slicer, just like the K2+. For users with printers from different brands, being able to manage them all with a single installation of Orca Slicer is a huge advantage. Now for the cons. 1. The print speed of this machine isn't the fastest, but falls within the average range among the latest Clipper printers. It still prints faster than the BambuLab A1, though not as fast as another bed slinger I recently tested, the Sovol SV06 Ace. However, the Creality HI features more robust hardware than the SV06 Ace, so it should be able to print even faster. I would recommend that Creality introduce multiple print profiles, such as balance, high speed, best quality, and rigidity, to allow users to fine-tune the printer based on their specific needs and fully unlock its potential. 2. Bed leveling before each print is optional, but when enabled, it performs the full 49-point probe. Ideally, it should only probe the printing area, similar to Prusa machines, for greater efficiency. Currently, enabling calibration adds unnecessary time to the preprint process. 3. The y-axis has an unprotected gap, and as the nozzle wipes at the back of the print bed, residue will likely fall onto the base. Over time, I wouldn't be surprised if some residue gets into the gap. 4. The angle of the Bowden tube is odd. I believe Creality designed it this way on purpose to prevent the filament from pushing back and tangling when the gantry moves all the way up for leveling. However, this awkward angle makes it harder to feed filament. 5. It can't print regular TPU. I tried printing with my Arion 95 ATPU without the CFS, using only the external spool holder, but it was unsuccessful. The filament simply wouldn't extrude from the print head. After confirming with Creality, I found that this machine can only print their HP TPU, which prints faster than regular TPU, but may be less flexible and more expensive. 6. It seems a bit odd that the CFS hub is mounted using double-sided tape instead of having dedicated mounting holes on the frame. I'm surprised they didn't design it with a more secure attachment method. Additionally, the CFS units are non-stackable, which could have been improved with a flat-top design. While you'd still need to unstack them to change filament, being stackable would help save space most of the time. In conclusion, the Creality HI is a solidly built machine that performs well, but the big question for most users is how does it compare to the BambuLab A1? In my opinion, Creality adopted some features from the BambuLab AMS, which is used in their mid and high-range P and X series, and integrated them into their CFS system. This design allows the CFS to work with both their flagship K2 Plus and the Creality HI, an entry-level bed slinger. With support for up to 4 CFS units, it enables printing with up to 16 colors compared to just 4 on the A1. When it comes to multi-filament systems and expandability, Creality's CFS takes the win over the BambuLab AMS Lite. However, they are both the same cut-and-poop filament system, while the biggest drawback remains excessive filament waste during color changes. If a manufacturer adopted the Prusa MMU3 approach, retracting filament instead of cutting it, while integrating the system into a compact, self-contained unit, it could combine the advantages of both methods and truly stand out in the market. For single-color printing, in terms of print speed and print quality, the A1 has slightly better print quality, while the Creality HI prints faster. I believe this is primarily due to the print profile settings in the slicers, so I'd call this a draw. Both machines support a similar range of materials, as their maximum nozzle and bed temperatures are identical. However, there is one minor difference. The A1 can print regular TPU when not using the AMS Lite, whereas the Creality HI can only print high-speed TPU. So, if more flexible 95 ATPU printing is important to you, the BambuLab A1 gets the point. When it comes to print volume, the A1 has a 256 by 256 by 256 millimeter build area, while the Creality HI offers 260 by 260 by 300 millimeters, which is about 20% larger. If you need that extra space, then the Creality HI is the winner here. For software and UI, the A1 has a better screen interface, displaying more information during calibration. Additionally, Bambu Studio remains a superior slicer compared to Creality Print, even though the Creality HI has a profile in Orca Slicer. However, since Orca Slicer is based on Bambu Studio, Prusa Slicer and Slick 3R, but mainly based on Bambu Studio, the software advantage still goes to BambuLab. As for price, the Creality HI holds only a marginal advantage over the A1. However, considering that the Creality HI features slightly higher cost hardware while still being cheaper, this point goes to Creality. It looks like Creality has changed its strategy, moving from budget-focused machines to advanced feature-packed models, starting with the K2 Plus. I think they've done a great job with this release. Without a doubt, this is the strongest competition for the BambuLab A1, offering a budget-friendly, high-performing bed slinger with multicolor printing capabilities. So, I will add it to my recommendation list as the best-performing all-rounder bed slinger. My website, auroratechchannel.com, also tracks and monitors the prices of popular machines, helping you find the best deals. All links can be found in the video description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.